In our previous lecture, we have learned about Cannizzaro reaction, one of the named reactions in organic chemistry. Today, we shall continue with the named reactions in organic chemistry and learn about Aldol condensation reaction. Aldol condensation reaction consists of two parts. One is Aldol formation, another is Aldol condensation, that is removal of water from the aldol formed. What is aldol? Aldol is a compound having two functional groups. Ald means aldehyde functional group, ol means alcohol functional group. So this compound will have alcohol as well as aldehyde functional group, so it is called aldol. Aldols are formed by two molecules of the same aldehyde or ketone, that is, they are the carbonyl compounds having at least one alpha hydrogen atom. So, two molecules of same aldehyde or ketone can form aldols or ketols. They undergo addition reaction. So, this is a self-addition reaction between two molecules of aldehyde or two molecules of ketone having at least one alpha hydrogen to form aldol by aldehydes or ketols by ketones in presence of a dilute alkali like sodium hydroxide, potassium hydroxide or barium hydroxide acting as a catalyst. So this is aldol formation. Let's take the example of aldehyde first. The simplest aldehyde having alpha carbon is acetaldehyde. CH3 C double bond OH is acetaldehyde. It is also called methanol. Acetaldehyde combines with another molecule of acetaldehyde in presence of dilute sodium hydroxide or potassium hydroxide acting as a catalyst to give us aldol product. Acetaldehyde, this is carbonyl carbon, this is the alpha carbon. Adjacent to carbonyl carbon is alpha carbon. This alpha carbon has 3 hydrogen atoms. So it has 3 alpha hydrogens. So it can undergo aldol formation reaction. Two molecules of acetaldehyde combine to give us aldol product, that is CH3 CHOH CH2 C double bond OH. This is called 3-hydroxybutanol because it has 4 carbon atoms, 1, 2, 3, 4. So it is butane. It has hydroxy group attached to third carbon atom. So it is 3-hydroxy. There is a CHO group on this compound. So this is NAL, the al, that is butanol. So it is 3-hydroxybutanol. It is also called beta hydroxyaldehyde because hydroxyl group is attached on beta carbon. This is the carbonyl carbon. This is alpha carbon. This is beta carbon. So hydroxyl group is attached to beta carbon. So it is called beta hydroxyaldehyde. Let us see how aldehyde, or in case of ketone it is called ketol, is formed. So first let us see this aldol. Okay. CH3CHOH. This is OH is alcohol functional group. CHO is aldehyde functional group. So it is called aldol because ald means aldehyde functional group, ol means alcohol functional group. So it has both. So it is called aldol. Okay. Now let us see ketone. This CH3 C double bond O CH3 is called acetone or propanone. This has two alpha carbon atoms on either side of the carbonyl carbon. We can take any one carbon. Each carbon has 3 hydrogen atoms attached to it. So altogether it has 6 alpha hydrogens. This acetone, represented in blue ink, will combine with another molecule of acetone, that is represented in green ink. This is also an acetone. In presence of dilute sodium hydroxide or potassium hydroxide acting as a catalyst, it will give us ketol product. Ketol products are also considered as aldols because of the similarity between aldehydes and ketones. So this is also considered as aldol product, though it is a ketol product. So we get CH3, COH, CH3, CH2, C double bond O, CH3. This is 4-hydroxy, 4-methyl, pentan 2-one. This has 1, 2, 3, 4, 5 carbon atoms in the longest chain. So it is pentane. It has a hydroxyl group on 4th carbon and methyl group on 4th carbon. So it is called 4-hydroxy, 4-methyl, pentan 2-one because there is ketone group present on 2nd carbon atom. So it is 4-hydroxy, 4-methyl, pentan 2-one. This is also called beta-hydroxy ketone because this is the carbonyl carbon, this is alpha carbon, this is beta carbon. Beta carbon, on the beta carbon we have hydroxyl group. So it is called beta-hydroxy ketone. This is a ketol product formed by aldol formation of 2 molecules of acetone. Let us see how it is. This OH group is alcohol functional group. This C double bond O is ketone functional group. So this compound has both alcohol as well as ketone functional groups on it. So this compound is called ketol, meaning this is keto group, functional group. This is alcohol ol, functional group. So this is keto plus ol, ketol. This is the formation of ketone. In this aldol formation reaction by 2 moles of acetone. Now let us see the trick to write aldol formation reaction. For this, first let us take acetaldehyde. First molecule of acetaldehyde is written in green ink, blue ink, CH3 C double bond O H. This is acetaldehyde or methanol. It combines with another molecule of acetaldehyde. This second molecule is written as CHHH. CH3 is written as CHHH for our convenience, so that we can show the reaction. This H and this H and these 3 H's are alpha hydrogens. Move one of the alpha hydrogens to oxygen atom of the first acetaldehyde. Then combine this carbonyl carbon with the alpha carbon of the second molecule of the acetaldehyde. This occurs in presence of dilute sodium hydroxide acting as catalyst. So when we join alpha hydrogen atom to carbonyl carbon of the first acetaldehyde, which is represented in blue ink, we get CH3 CHOH. Remove. See, please note that this O is written in blue ink and H is written in green ink. H is from the second molecule of acetaldehyde. After giving out a carbon, after giving out an alpha hydrogen, this carbon is left with two atoms of hydrogen. So it is represented here as CH2. So this carbonyl carbon is attached to alpha carbon of the second molecule of the acetaldehyde to give us CH3 OH CH CH2 C double bond OH. This is 3 hydroxy butanol because there are 4 carbon atoms 1, 2, 3, 4. So it is butane. Nol because there is CHO group, aldehyde group present here. Hydroxy because hydroxyl group is present on third carbon atom. So it is 3 hydroxy butanol. This is the simple way of forming aldol. Hope you understood. This is also called beta hydroxy aldehyde because hydroxyl group is found on beta carbon. This is the carbonyl carbon. This is alpha carbon. This is beta carbon. OH is attached to beta carbon, so it is called beta hydroxy aldehyde. Now let us see ketol formation of how ketol formation is written for acetone. First molecule of acetone is written as CH3 C double bond O CH3. This is written in blue ink. Second molecule is written in green ink so that you will know the difference. This CH3 is written in elaborated form CHHH C double bond O CH3. This is also acetone. We join this alpha hydrogen atom to oxygen atom of the first molecule of the acetone, and we combine this carbonyl atom of the first molecule of acetone to alpha carbon of the second molecule of acetone. So we get CH3 COH CH3 CH2 C double bond O CH3. This CH3 which is present on this side of the carbonyl carbon is written down here. So this becomes a 5 carbon atom compound. 1, 2, 3, 4, 5. So it is a pentane. Hydroxyl group is present on 4th carbon atom. Methyl group is also present on 4th carbon atom. So it is called 4 hydroxy, 4 methyl, pentan, 2 one because second carbon has the ketone functional group. So this compound is having OH alcohol functional group as well as keto functional group C double bond O. So it is called ketol. This is also called beta hydroxy ketone because the hydroxyl group is present on beta carbon. This is the carbonyl carbon, this is alpha carbon, this is beta carbon. So it is also called beta hydroxy ketone. This is how we write aldol formation reaction in a single step. Now let us see what is aldol condensation. Aldol condensation means removal of hydrogen and oxygen, that is removal of water from aldols or ketols formed in the aldol formation reaction. So when the water is removed on heating, we get alpha beta unsaturated carbonyl compounds. These alpha beta unsaturated carbonyl compounds are called Aldol condensation products. Let us see how it is formed. So first we have taken 3-butanol CH3 CHOH and CH2 is written as CH and H, C double bond OH. This is 3-hydroxybutanol. This is the aldol. And we heat it. When we heat it, this alpha hydrogen of alpha carbon of the second molecule of acetaldehyde and OH will join together to form water, and it is eliminated as water molecule. As a result of which, this bond between OH and carbon will shift here. So we get CH3CH double bond CH, because one hydrogen is gone. So only one hydrogen is left, CH, C double bond OH. This is but-2-enol. Why? Because it has 4 carbon atoms. 1, 2, 3, 4. So it is butene. Double bond is there. Double bond is present on second carbon atom. So it is but-2-en. All because there is CHO group. C double bond OH. This is aldehyde group. So this becomes but-2-enol. This is also called alpha beta unsaturated carbonyl compound, because this is carbonyl carbon, this is alpha carbon, this is beta carbon. The double bond is present between alpha carbon and beta carbon. So it is alpha beta unsaturated carbonyl compound. These alpha beta unsaturated carbonyl compounds are called Aldol condensation product. Okay. That is, by removal of water, we are getting this alpha beta unsaturated carbonyl compound. This is for acetaldehyde. Now let us see for the aldol condensation product of ketones. We have formed ketol in the previous reaction. That is 4-hydroxy 4-methyl pentan 2-one. This is it. CH3 COH CH3 CH2 C double bond O CH3. This hydrogen, alpha hydrogen, then OH of this carbon will join together upon heating to give out water molecule and give us aldol condensation product or ketol condensation product. As a result of that, we will get CH3 CH3 C double bond CH C double bond O CH3. This compound has 5 carbon atoms, so it is pentane. There is a methyl group on 4th carbon atom, so 4-methyl pent. On the 3rd carbon is the double bond, so 3-en 2-one, because on the 2nd carbon atom is the ketone group, that is C double bond O present. So it is 4-methyl pent 3-en 2-one. This is also called alpha beta unsaturated carbonyl compound, because the double bond is present between alpha carbon and beta carbon. So this is alpha beta unsaturated carbonyl compound. This is the aldol condensation product or ketol condensation product. So this is how water molecule is removed, which is called aldol condensation. Now let us see how to write aldol condensation product directly without writing aldol formation and then aldol condensation. So let us consider the trick to write aldol condensation directly. Here we have written one molecule of acetaldehyde in blue ink, another molecule of acetaldehyde in green ink for you to understand very easily. First molecule is CH3, C double bond O, H. This is acetaldehyde. For the second molecule of acetaldehyde, we have elaborated CH3 as CHCHH. So it has 3 alpha hydrogen atoms. We combine in presence of dilute NaOH acting as catalyst and in presence of water, we can directly write aldol condensation product. This oxygen of the first molecule of the acetaldehyde will combine with two alpha hydrogen atoms of the second molecule of the acetaldehyde to give out a water molecule. As a result of this double bond will be shifted to between this CH and this alpha carbon. So we get CH3 CH double bond CH C double bond O H. This is but2-enol. There are 4 carbon atoms, so it is butane. Double bond is present between second carbon and third carbon, so it is 2-ene. All because there is this CHO present, that is aldehyde functional group is present here. So it is called but2-enol. So upon condensation, aldol condensation of acetaldehyde, we get but2-enol as the condensation product. This is also called alpha beta unsaturated carbonyl compound. Carbonyl compound because C double bond O is present. There is a double bond between alpha carbon and beta carbon, so it is called alpha beta unsaturated carbonyl compound. Let us see for how acetone undergoes aldol condensation reaction in presence of dilute potassium hydroxide acting as catalyst and heat. First molecule of acetaldehyde is written as CH3 C double bond O CH3. Second molecule of acetone is written in green ink. CH3 is elaborated as CHHH. 3 alpha hydrogens this CH3 is having because this C is alpha carbon adjacent to carbonyl carbon. C double bond O CH3. This is second molecule written in green ink. The oxygen of the first acetone will combine with 2 alpha hydrogens of the second molecule of acetone to give out water. As a result of which, this double bond on this carbonyl carbon will be shifted to this alpha carbon. This CH3 will come down. So as a result, we get CH3 C double bond CH and CH3 here, C double bond O CH3. It has 5 carbon atoms, so it is pentane. 1 2 3 4 5. There is methyl group on the 4th carbon atom, so it is 4-methyl pent 3-ene because double bond is starting at 3rd carbon atom. 3-ene 2-one because on the 2nd carbon is the carbonyl functional group, ketone functional group, that is. So it is 2-one. So it is 4-methyl pent 3-ene 2-one. This is also called alpha beta unsaturated carbonyl compound because this is the carbonyl carbon, this is alpha carbon, this is beta carbon. The double bond is between alpha and beta carbon atoms. So it is alpha beta unsaturated carbonyl compound. This is the condensation product of acetone when it undergoes aldol condensation reaction in presence of dilute alcohol. So this is single step and easy way of writing condensation products. If you are asked about aldol condensation reaction, write the definition given in previously and write this single reaction. This will be enough for writing aldol condensation reaction. Hope you understand. Now let us see the mechanism involved in aldol formation. The mechanism takes place in 5 steps. Okay. In step 1, enolate ion is formed. What is enolate ion? Enolate ion is nothing but ion formed by acetaldehyde with negative charge. Let us see how it happens. CH3 I have written this side. For convenience sake, C double bond OH of the acetaldehyde I have written here. This is represented in first molecule is represented in blue ink. Now we have taken the catalyst sodium hydroxide. Sodium hydroxide exists as Na plus and OH minus. You all know that OH minus is a nucleophile. This nucleophile attacks the alpha hydrogen atom of the acetaldehyde, first molecule of acetaldehyde, and removes alpha hydrogen atom from this alpha carbon and becomes water. I have written water as HOH. This H is from this alpha carbon of the first molecule of acetaldehyde. So OH is from NaOH. Okay, this is written in yellow color for you to understand. So when this happens, this molecule will be left with 2 electrons of the CH bond. So this becomes H C double bond O CH2 with 2 electrons. This carbon will have negative charge on it. So this is called enolate ion. CHO CH2 minus charge is called enolate ion. So what happens here? Nucleophile OH from dilute NaOH attacks alpha hydrogen atom of acetaldehyde, first molecule. 2 bonding electrons of CH bond are left with CH2. So it becomes enolate ion, that is CH2 minus with 2 electrons. In the step 2, the enolate ion attacks the second molecule of acetaldehyde. So the enolate ion is negatively charged, we know that. This negatively charged CH2 minus enolate ion attacks the carbonyl carbon of the second molecule of acetaldehyde. This acetaldehyde is written in green ink to differentiate first molecule and second molecule of acetaldehyde. This carbonyl carbon is slightly positive because of slightly electronegative of oxygen atom. You know, oxygen atom is more electronegative than carbon atom. So it pulls the pi bonded electrons towards it. So it becomes slightly electronegative. As a result of which, this carbon will become slightly electropositive. Since it is slightly electropositive, this enolate ion, which is negatively charged, will attack this carbonyl carbon and gets attached itself on the carbonyl atom, forming a bond. So as a result of which we get CH double bond O CH2 CH CH3 O minus, because this pi bond between carbon and oxygen will break and oxygen will get pull both the electrons towards it. It becomes negatively charged. So now this entire molecule is like this with a negatively charged oxygen atom. So what happens here? Enolate ion attacks slightly positive carbonyl carbon. As a result, the pi bond of C double bond O breaks to form negatively charged oxygen atom. This negatively charged oxygen atom accepts a proton from the water molecule formed in the step 1. Remember, the water formed in the step 1 is HOH. This will take back the H plus ion from water. So oxygen accepts the H plus, that is proton, from HOH, that is water. As a result of which we get OH attached to this oxygen. So this becomes CH double bond O CH2 CH OH CH3. This is nothing but 1 2 3 4 1 2 3 4 4 butanol, 4 hydroxybutanol, 4 hydroxy, because hydroxyl group is present on 3 hydroxybutanol. 1 2 3 hydroxyl group is present on third carbon atom, so it is 3 hydroxy butanol. Nal, because this is the functional group CHO. We have written left side instead of right side, that's all. So don't get confused by it. So this is Aldol formation product. Now what happens to this OH minus ion which was left behind? In step 4, the OH minus ion of water combines with Na plus to give NaOH. So the catalyst is recovered. OH minus combines with Na plus to become NaOH. So the catalyst is recovered, that is sodium hydroxide, dilute sodium hydroxide. In step 5, the aldol formed in the third step upon heating gives aldol condensation product, that is water molecule is removed from aldol formation product. CHO, CH2, CHOH, CH3. This is aldol because it has alcohol group and aldehyde group. This hydrogen and this OH will join together to form water molecule, and water molecule is eliminated, as a result of which we get but2-enol. 1 we count from this side because functional group is present on this side. So 1 2 3 4. On the second carbon is the double bond, so 2 in, all because there is aldehyde functional group here, CHO. So this is but2-enol. This is the Aldol condensation product. This is also called alpha beta unsaturated carbonyl compound because the double bond is present between alpha carbon and beta carbon. So this is alpha beta unsaturated carbonyl compound. This is the condensation, aldol condensation product of acetaldehyde. The above mechanism is useful for those who are interested. Other students can just learn aldol condensation reaction given previously, which is given in only single step. You can write that. Before that, you write the definition of aldol condensation. That will be enough. For others who are interested in mechanism, this mechanism part can be learned. Okay, this mechanism consists of 4 steps. So you learn that. Now there is the difference between Cannizzaro reaction and aldol condensation reaction. Cannizzaro reaction is given by aldehydes or ketones which do not have alpha hydrogen atom, and they two molecules of aldehyde or ketone will undergo disproportionation reaction, that is self reduction and oxidation reaction, to give one molecule of alcohol and another molecule of carboxylic acid salt. So that is disproportionation reaction. Aldol formation is given by aldehydes and ketones which have alpha hydrogen atom and they give only a single product, that is aldol or ketol, and this product is formed by the addition of aldehydes or ketones having at least one alpha hydrogen atom. These are the main differences between Cannizzaro reaction and aldol condensation reaction. Thanks for listening. Please subscribe, share and like. Thanks a lot.